Hello guys, so welcome to my YouTube channel. So in this video I'm gonna teach you the CATION analysis. Okay, so we go into the video. So this also called the group analysis. Okay, CATION analysis also called the group analysis. So basically this consists with six groups. Okay, six groups. We consider them as group 1, group 2, group 3, group 4, 5 and 6. Okay, so the idea, so basically the idea is, so imagine, okay, imagine this beaker contains a cation sample. Okay, different cation samples. Okay, I'll show different colors. Okay, imagine that this beaker contains different cation samples. Okay, so from cation analysis, what we're gonna do, we're gonna test this sample with different solutions, and we're gonna react with different solution and to find different cations by their precipitates. Okay, by their precipitates. So uh, let's go into the lesson. So imagine this beaker contains as I said previous, this contains different cations. In group 1, okay, we gonna okay, in this so to this sample, first we gonna add dilute HCl. Okay, dilute HCl should be added to the mixture, cation mixture. Then we obtain some precipitates. Okay, so with the colors of the precipitate we can conclude cations. Okay, so from first group analysis, when we add HCl to this mixture, it will give three type of different ions. Okay, if it contains lead plus, okay, okay guys, so if this cation contains silver plus, it will react with HCl and form AgCl. Okay, that form AgCl. So the color of this PP, the precipitate, is what? It's I okay. I'll show the gray. It's gonna be white. Okay, that white. If this mixture contains Ag2 plus, so it forms AgCl and that precipitate as white color. Okay, so the second element we can take is the mercury, plus. Okay, if it contains mercury plus, actually we write this as Hg2 2 plus. Okay, Hg2 2 plus. If this mixture contains mercury 2 2 plus, it forms Hg2Cl2, and this also precipitate as white color. So the last ion we can identify from this test going to be lead, Pb2 plus. So this gonna react with dilute HCl, and this will give PbCl2, and this also gonna white color. So this is the group 1 analysis, guys. So when dilute HCl added to a cation sample, these precipitates get evolved. So we can identify silver, mercury and lead. So by second we take that sample. Okay, the precipitate sample that we obtained in previous one, that means the first group analysis, is filtered. Okay, actually it's filtered, and we going to filter and take that filtrate. Okay, remaining fluid, and again it used for the next steps. Okay, so in second we going to in second step we going to, so this is the cations, we going to bubble, we going to bubbling of H2SO4, H2SO bubbling. Okay, so always remind guys, this solution is already acidic solution. As previous stage we add dilute HCl. Okay, then this H2S bubbling we going to do to this sample. So as a result we have actually the largest cations can be cation precipitates can be obtained from this. Okay, so in first we can get lead. Okay, actually you remember guys, lead also found in the first. Actually this is why in first first stage lead actually small amount only precipitate. Okay, so in this step the whole lead shows this reaction, the remaining whole lead 2 plus. Okay, then it turns to lead sulfide. Okay, then we can identify bismuth. Bismuth 3 plus. it will going to Bi to S3 by reacting with this H2S. Okay, so in third we can get copper 2 plus, and this gonna be copper sulfate. And fourth one is we're gonna take mercury. Previous stage, the means the first group analysis, we identify mercury plus. Okay, remember that this is Hg2 plus. Okay, it will convert to mercury sulfide. So this all the colors get all this precipitates get black color. Okay, this get black color, so we can identify this contains these ions. Not only this, okay, not only this, we can also get 5 iodide tin. Okay, tin 4 plus. This convert to tin sulfate. As 6 we gonna take cadmium 2 plus. It precipitates as cadmium sulfide. This gonna take arsenic 3 plus. That precipitate as S2 S3, and we have another one 8 tin 2 plus. Okay, guys, this is tin 4 plus, this is tin 2 plus, this tin 7. Not the last one. Okay guys, the last one is antimony. We can get antimony 3 plus identified by this reaction, get Hp to S3 by reaction with H2S. So guys, this colors, so those colors are, these three have yellow color. Okay, these three precipitates are yellow color. Then this contains brown color. This one contains orange color. Okay guys, I write it as OR. So antimony, it gets orange color from this H2S in second group analysis method. Okay, that's done. Then we can go to the third group analysis, which means third group cation analysis. So that what we're gonna do is we're gonna take that filtrate the precipitates in the second group analysis, and we're gonna filter that precipitates, and remaining solution we take again and do this next steps to that reaction. Okay, so what we're gonna do is we're gonna take the residue fluid and we're gonna boil this. Okay, we're gonna boil this. Why we gonna boil this? To remove S2S. Okay, to remove the remaining H2S, we're gonna boil this. Then again we're gonna add HNO3 and heat it. To why we gonna add nitric and heat it? To convert Fe2 plus, the remaining Fe2 plus to Fe3 plus. If it present Fe2 plus, it may be somewhat difficult to get these reactions to convert Fe2 plus into Fe3 plus. We're gonna add nitric to this solution. Okay, then we're gonna again add NH4Cl. Yes, NH4Cl to this mixture. NH4Cl and NH4OH to get basic medium. Okay, to get a basic medium, to get a low concentrated basic medium. Okay, so by doing these things, after we can get 3 anions. Okay, so first we can get aluminium 3 plus. It will precipitate as LOH3. And second, we can get chromium 3 plus, and it will precipitate as like this. And finally we're gonna ferrous 3 plus, and it precipitate as like this. So we're gonna have chromium 3 plus, and it precipitate as chromium hydroxide. We gonna have ferrous 3 plus, and it precipitate as ferrous hydroxide. So the color of this is white gelatinous. Okay, white gelatinous. So color of this is gonna take blue because it's blue green. Okay, that's blue green. Color of this is, yeah, it's red brown. So that's the third group analysis. We can get aluminium, chromium, and ferrous. We can identify aluminium, chromium, and ferrous ions. So next we going to the group 4 analysis. Okay, group 4 analysis. Then the previous precipitates get filtered, and the remaining fluid get and do our test. Okay, so in this fourth analysis, we gonna again bubbling H2S bubbling to this solution. Okay, So in this, H2S is in OH medium. OH medium. So from this, we're gonna take 4 precipitates. Means we're gonna identify 4 cations. So first going to be cobalt 2 plus. Cobalt 2 plus. It's converted by getting sulfide and cobalt sulfide. And the next we're going to have nickel 2 plus. This convert to nickel sulfide. And as third one, we're going to have manganese 2 plus that convert to manganese sulfide. Last we have zinc 2 plus, it convert to zinc sulfate. Okay, so this two gets black color, guys. Okay, this one get pink color, and this get white color. Okay, so group 4 analysis also done, guys. So we're going to next is our group 5 analysis. So I just teach you that the basic ideas and basic knowledge about the cation analysis. Okay, so in group 5 we're gonna have the initial precipitate was again filter, and the remaining solution get and other things get done. Okay, so what we're gonna do to this solution is we going to add NH4Cl and NH4 ammonium carbonate, NH42CO3 actually, to this solution. So this will give precipitate calcium 2 plus. It will convert to calcium carbonate, and this strontium 2 plus, and that gonna convert to strontium carbonate. So for third one is barium 2 plus, that convert to barium carbonate. Okay, so as usual, this is easy actually, guys. This whole 3 gonna white color. So yes, that's group 5 totally done. So guys, our next and final analysis, group 6 analysis. Okay, guys, group 6 analysis. So in group 6 we're gonna add the remaining fluid. We gotta add 8. So remember this very carefully. Okay, 8 hydroxy quinoline. Okay, 8 hydroxyquinoline is added to that filtrate. Then this magnesium in this fluid, magnesium 2 plus fluid, forms precipitate, and it gives yellow color. Okay, it gives yellow color. So that's it. That's the basic concepts in cation analysis. Okay, that's the basic concept in cation analysis. So guys, hope you enjoy my video. So I please recommend you to watch my other videos also, and subscribe my YouTube channel, share this with your friends. So hope you guys enjoying the video. So goodbye to you all guys. Thank you.